Welcome to the Allplan QuickStart Lesson 5. In this lesson, we'll learn how to add openings to walls and complete the roof framing plan. If you haven't done so already, make sure to complete Lesson 4 before proceeding to this lesson. We'll start by adding openings to the exterior first floor walls. Double-click on the modeling space to open the building structure. For this exercise, we'll only have the second floor plan open in order to model the openings in the first floor walls. To quickly open a single active drawing file, double-click on the name of that file. Double-click on the drawing file 200 second floor plan start. Allplan makes creating doors and windows easy. Start by selecting the loading door in the QuickStart wizard by double right-clicking on the command. The door properties have already been defined through the wizard. Notice the anchor icon in this dialog box. This will define the reference point where the door will be modeled. Right now it's at the lower left-hand corner. Notice when I hover over the wall, the start point of the door is at the corner. If I change this to the center point, the door will be drawn based off the center. Keep the reference point at the corner, and click in the model about where the door needs to go. At this point, you do not need to be exact. Notice there's an arrow and a solid square. The arrow is the reference point and the square is the corner of the door. Follow the instructions in the command bar at the bottom of the screen. First, we need to make sure the reference point is at the exterior corner of the wall. Zoom in, and if needed, click on the corner to make sure the reference point is correct. Now in the command bar, type 5 foot for the distance from the corner reference to the start of the door and press enter. The command bar is recognizing the door width from the predefined properties of the wizard. It should indicate 12 foot 6 for the opening width. Click enter to confirm. The door is now modeled and we can see it both in plan and 3D animation view. We are still in the loading door command. In the property dialog box, change the anchor point to the bottom right hand side. Now hover over the exterior wall and make sure the red X of the anchorage point is on the exterior portion of the wall. Now click near the bottom of the wall to start modeling the door. Again, make sure the reference point is at the corner of the wall and click on the corner if needed. Type 5 feet for the offset from the reference point and click enter. Confirm the 12 foot 6 width and press enter to complete. We will now repeat this process for the two exterior doors along the south walls. In the wizard, double right click on the tip door. Make sure to click on the door opening element and not another portion of the wall or the door. Check the tooltip to verify that you're selecting the correct element. Click near the re-entrant corner of the south wall and confirm the reference point is at the exterior corner. Type the offset distance as 9 feet and click enter. Notice the command prompt recognizes the door width of 6 feet and press enter to confirm and model the door. Now change the anchorage point to the bottom left-hand corner and repeat the process for the southernmost wall. Set the reference dimension of 6 feet and confirm the 6 foot width of door. Press escape to exit the command. Next, we'll model the exterior windows along the southern wall. In the wizard, hover over the tip window element. Notice as you move our mouse, there are several components to the window. Make sure to double right click on the component that indicates window opening. The process for modeling the windows is the same as for the doors. Make sure the anchorage point is set to the bottom left-hand corner and click on the wall. Set the reference distance to 9 feet and confirm the 6 foot width of the door. Now notice the command bar. It's prompting us to right-click to confirm. Click on the right mouse button to finish the window and to start a new window. Click to the right of the first window. The reference point is now at the end of the first window, so we can simply type in the distance between windows. This makes creating windows along a line of wall very easy because we don't have to go back to the reference point at the edge of the wall, but can simply know what the distance is between the different openings. Type 6 feet for this window-to-window spacing and press enter. Confirm the 6 foot window width, again with enter. Now right-click to complete and stay in the command. Click on the western wall at the re-entrant corner. Set the reference distance to 7 feet and press enter. Confirm the 6 foot window width by pressing enter and then escape twice to exit the command. We've now completed the first floor doors and windows. We'll add one more type of opening to this level, and that's the slab openings. First, let's turn on the grid lines in order to take advantage of Allplan's area detection. Double-click in an empty portion of the viewport to open the building structure. Set drawing file 3 grid lines to reference mode. Back in the model, click on the slab opening command in the Elements ribbon. Notice the command bar prompt for the next move. Click on the slab to select it. Make sure the area detection command is checked on here in this Properties window. Now you can simply click in the area that's defined by the walls and the grid line to create the slab opening in this area. You can see the opening in both the plan and the 3D animation view. Allplan makes it easy to modify objects once they've been modeled. With direct object modification, we can simply click on an element and actively make changes to it. Click on a window opening. Notice there are 3 snap points as well as dimension markers. You can type directly into the dialog boxes to change these values. For example, in the left box, change the location of the window from 9 feet from the reference corner to 5 feet. Use the center dialog box to change the width of the window. The arrows below control the reference edge so the program knows which side to modify if you're changing the width of the window. You can also use the snap points to drag the width of the window or the location of the opening. We encourage you to play around a little bit with the direct object modification. This command does work on all elements within Allplan, so we can click on the column, for example, and quickly change its dimensions. We don't have to go into the Properties window to do this, we can do it right within the model. We can also change the length of a wall, for example. If you've made changes, make sure to undo to go back to the original dimensions of all of the elements within the project. Another way we can modify the building easily is by changing the story heights. As I've mentioned, the elements are all referenced off the defined story heights. If the building elevation changes, we need to make this change in one place and everything changes with it. Double-click in an empty viewport to open the building structure. Open the Floor Manager. Either in the table or the graphics, click on the dimension to change the floor-to-floor height for the first floor walls. Change this value to 15 feet. In the dialog box, indicate to retain the height of the levels below and move up the levels above. Click OK on the next dialog box. Now close the building structure. Notice how all the walls have increased in height. The windows and doors are referenced off the lower plane elevation, and that's why they're still at the same height above grade. Now go back into the building structure, open the Floor Manager, and change the bottom slab at the second floor back to 9'2". Retain the height below and move down the levels above. Click OK twice to confirm. We're now ready to model the roof framing plan. In the building structure, turn the grid lines to reference mode and set the roof plane start drawing file 300 to active. Deactivate all other building files and click close to confirm. We'll start by modeling the second floor walls. This is the same process we used for the first floor walls in lesson 4. However, this time we do need to modify the planes that were used to reference the wall heights. In the wizard, double right click on the exterior stud wall with brick. Open the properties for the wall. Click on height to adjust the reference planes. For the top level, click on the plane name and change it to the top level structure. This wall will have a parapet and it will span above the roof slab up to the very top level that we've defined for this particular building. Click OK to confirm, and now select the bottom level plane and set this to top of slab second floor. In the main properties window, check the box to have the same height for all layers. Note that you can have a wall with multiple layers and different heights for each layer. So for example, if there is a step or a notch in the wall. Click OK to finish and return to the model, and now we can start drawing the second floor walls. The second floor has a step back in the building, so the exterior walls are going to start at grid line 3 and then go around the perimeter of the building. Let's repeat this process for the interior concrete shear walls. In the wizard, double right-click on the interior 8-inch concrete element. Go to the Properties and click on Height. This time, set the top level to the bottom of roof slab level. The interior walls will stop at the bottom of slab. Then set the bottom level to the top slab second floor plane and click OK to confirm all dialog boxes. Now model the interior walls similar to the first floor from Lesson 4. Next, model the center column at C4. In the wizard, double right-click on the column element. Similar to the walls, we need to go to the Properties and adjust the reference planes. In the height property, change the top level to bottom of roof slab and the bottom level to top slab second floor. Make sure to rotate the column by 90 degrees using the command bar prompt at the bottom of the screen, and then snap to the intersection grid lines. We can model the beam along grid line C in the same way. In the wizard, double right-click on the 14 by 24 beam element. In the beam properties, go to the height. Notice this different location in this particular properties box. Change the top and bottom levels to the bottom of roof slab level. For the beam, both top and bottom are referenced off the top plane, and the bottom is just an offset from that plane. Also note, in this case, we're treating the bottom roof slab level as the top of structural concrete slab, and assuming that it's the bottom of any unfinished flooring that will go on top of this concrete slab. Click OK to confirm all dialog boxes and model the beam along grid line C. Now let's model the roof slab. Again, double right-clicking in the wizard for the floor slab. In the properties, we're going to make changes to now use this basic floor slab as a roof slab. So go to the height and set the top level to bottom of roof slab. This time we're going to set an absolute value for the thickness of the slab. At the bottom level, change the reference criteria to fixed component height. Now set the offset to 8 inches. Click OK to confirm and model the slab around the perimeter from the interior face of the exterior walls. The final step is to create the second floor windows, and we'll use the same process we just used for the first floor windows. In the wizard, double right-click on the tip window command, making sure to select the window opening. Go into the window properties and make sure to change the reference plane to the top of slab second floor. Now starting at the corner of grid lines B3, model the first window 4 foot from the corner. Then the second window will be 5 foot from the first. And place a window in the perpendicular wall at 7 foot from either corner. Finally, place a single window on the southernmost wall at 6 foot from the bottom left-hand corner. Once done, click Escape to exit this command. We have now completed our building for the purpose of this Quick Start guide. To visualize the completed building, we can turn on all relevant drawing files. In the building structure, turn on the foundation plan, the second floor plan, and the roof plan. Make sure that 2 of these are in edit mode and 1 will be in active mode. You can now see the completed building in the 3D animation view. Allplan has built-in rendering and visualization capabilities. We can edit the 3D animation view to better represent the final structure. Hover over the bottom of the viewport to display the commands. In the drop-down menu at the right, you can control which view you're looking at: wireframe, animation, or others. Click on the pencil icon to modify the properties of this viewport. You can turn on or off to display shadows as well as other properties. Now, while in navigation mode, which again is the rotation command, right-click in the viewport and choose Surroundings. Here you can set up where your project is located, the time of year, and control the sunlight and shadows in the graphics. Once you've selected the visual settings, you can switch to a real-time rendering view. This will start to fully render the model using the Cinema 4D rendering engine built into Allplan. This allows you to get a preview of what the finished rendering may look like before committing to an actual rendering, which may take time to complete. This was a great way to get actual, lifelike pictures to show to your customers and clients. That completes Lesson 5 of the Allplan QuickStart Guide. In the next lesson, we'll learn how to create a wizard, views, and sections.